A clock is any device that counts events that occur at regular intervals. The event that drives a clock can be just about anything. The swing of a pendulum, the bounce of a ball, the unwinding of a spring, or the changing current in an electric circuit. Any regular event will do. Let's imagine constructing a clock in which a beam of light bounces between two mirrors. Whenever the light strikes the bottom plate, the clock advances. The advantage of using this kind of clock is that we can be sure that the observer who looks at the clock will see the timing mechanism, the beam of light, moving at the same speed. If two such clocks are stationary, then we would expect the time indicated on each clock to be precisely the same. But what happens when one clock is in motion? Notice although both clocks are identical, the moving clock ticks slower than the one at rest. In order to understand why, notice the paths of the light beams. The light in the stationary clock travels up and down vertically, but the light beam in the moving clock must travel a longer diagonal path. Since both beams travel at the same speed, and the upper beam travels a longer distance, the stationary observer sees the moving clock run slower than his own. This slowing down of clocks in motion is known as time dilation. It should be stressed that a person moving along with the moving clock would notice nothing unusual at all. The clock and the flow of time would seem to progress normally. According to this observer, he is at rest and the other observer is moving past him. According to him, it is the other clock that is running slowly. The flow of time in Einstein's universe is entirely relative.